In this video, I'll demonstrate how to complete the roughing of the pocket after the 12mm end mill has finished its helical entry. First, I'll rough as much material as possible with the 12mm end mill while maintaining a minimum of 2.5mm for the finished tool. Then I'll select a new tool which can clean up the remaining areas of the pocket where this end mill could not fit. After the helical entry of the cutting tool, the areas shown in red represent the remaining material to be removed with the roughing tools. The area shown in blue represents the 2.5mm which will be left for the finishing tool to remove. At the end of the helical entry, the tool will be here, so I'll start coating the remaining roughing from this location. After this 12mm end mill has finished roughing, the area shown in black will remain for the next roughing tool to remove. The tool could be programmed to remove slightly more material in each corner as shown here, but it will take more time than it is worth to calculate the tangent points. Instead, the center of the tool will be programmed so that the cutter removes the rectangular shape as shown. After the helical entry is completed, I'll program the cutter to move to X 18.5, then Y minus 24.5, then X 31.5, then Y minus 13.5, and lastly to X 24. This will see the starting position overlapped by 1mm, and next I'll rapid the cutter out of the pocket and send it to the tool change position. I won't bother arcing off because I'm not worried about a witness mark as there's still 2.5mm to be removed from the pocket wall. Now I'll need to select a new tool to clean up the areas as shown in black. First I'll need to determine the maximum cutter diameter, which will be 5mm. Since the 5mm part radius is being offset 2.5mm towards the center of the pocket, the radius as shown here will be 2.5mm, thereby limiting my cutter diameter to 5. In each of the four corners there will be a very small amount of material this cutter will not be capable of removing, as shown by the red area. However, since it is so small, I will not worry about it. The finished tool will clean this up. To complete the roughing, one pass following the profile as shown here will clean up all of the material. However, this will use up to 100% of the cutter diameter, which may break the cutter if the feed is just a bit too aggressive. So I'll remove this material with two 1.25mm passes taken at 4.5mm depth. I'll start the 5mm end mill on the center of the part in the x-axis so it can be fed down into the pocket and not engage any material, and at y minus 11.25. Then I'll feed the tool counterclockwise around the pocket. The next x coordinate will be x 13.15, the start of the arc. To calculate the x and y coordinates for the arc, the Pythagorean theorem will need to be used. The radius of the arc is 11.25mm, and the change in the y-axis from the center to the start of the arc is 7.75mm. This makes the y-coordinate at the end of the arc negative 26.75. The change in the x-axis for this triangle is 8.15mm, making the x-coordinate 13.15. Since the part is symmetrical about its center, the remaining coordinates are easily calculated for the rest of this roughing pass. Once the first rough pass is complete, the tool can now be repositioned in the y-axis to take the final rough cut. Again, the Pythagorean theorem will be used to calculate the x and y coordinates of the arc. Once these are known, the final rough pass can then be programmed as shown here. These tool paths will also work to finish the pocket if the ramp entry was used. In the next video, I'll demonstrate how to program the finished cutting of this pocket.